Good morning, everybody. Hope you're doing well. Happy Thursday. You know the drill. You pause this, you copy everything down, you try to solve all these questions and equations and quantities. Um, when you get stuck, you press play and get a hint, press pause again, or when you finish, you come back and see how you did. Okay, we'll see you in a bit. Okay, here we go. 48 and 14. What two numbers, when you multiply, are going to equal 48, and when you add will be 14? That's going to be an 8 and a 6, right? And remember, a 6 and an 8 works just like an 8 and a 6, because 6 times 8 is the same as 8 times 6. 6 plus 8 is the same as 8 plus 6. We call that the commutative property. Remember, it's like your mom's commute when she drives to work. Same distance there as back. Right, and it works with multiplying and adding. It does not work with dividing or subtraction. So we have commutative property of addition, commutative property of multiplication. We don't have a commutative property of division or subtraction. All right, 32 thousandths, 84 hundredths. What's going to work there? Well, 4 hundredths and 8 tenths. Remember, when you go add those, the key is to line up the decimal. You stack them one on top of there. So when I write that second number, remember what I do? I put the decimal first. Then I see there's a 0 on that side, 8 on that side. It forces me to line up the decimal and line up all the digits. Now this comes out to 2 spots. This only comes out to the 10th spot. We go ahead and add a 0. You're allowed to do that after decimal. And then I go add. I do get the 84 hundredths. When I multiply, I pretend there's no decimal. Go 8 times 4 is 32. But I had to move the decimal over 2 spots to pretend that was a 4, and 1 spot to pretend that was an 8. That's a total of 3 spots I moved in the problem to the right, so I have to move it back 3 spots in my answer. That's how that works. Okay, 2 ninths and 1. Did I stump you? Well, here's the deal. Think to yourself, what numbers multiply together equal 2? I just get 1 and 2, right? How about what numbers multiply together equal 9? Well, I get 9 and 1 and 3 and 3. 3 and 3 gives me the advantage of adding with a common denominator. And 1 and 2, when I do that, I end up 1/3 and 2/3. 3/3 is 1 whole. And 1 times 2 is 2. 3 times 3 is 9. Remember, multiplying fractions is, hopefully you're yelling, easy, right? Because you just go straight across the top, straight across the bottom. Not true when you add, okay? You have to get a common denominator, and then you add or subtract the tops. Same idea on this one. I have 1 whole, and I have 3/16, and I know that 4 times 4 is 16, and 1/4 plus 3 more fourths is going to equal 4/4, which is 1 whole. And 1 times 3 is 3. 4 times 4 is 16. Okay? That fool you? That stump you? Well, good. That means you learned something new. All right. What is your goal when you solve algebraic expressions, algebraic equations? Right? Why is it an equation instead of an expression? It has the equal sign. Remember what that equal sign does? It's like a seesaw. It's a perfect balance. Everything's in perfect balance. What does that mean? That means I can do anything to one side of the balance. As long as I do the same thing to the other side, it'll stay in balance, right? I could add 20 here. If I add 20 there, it stays in balance. I said subtract 118 here, and if I subtract 118 there, it'll stay in balance. Okay? Now, what is the goal with my question? Is to isolate the variable. I want x all by itself on one side of the equal sign. Right? Kicks everything else off the island. What am I saying? Island. Same thing here. The A wants to kick everything else off the island. Why do I say island? Well, how do you say island in Espanol? ¿Cómo se dice island? Isla. And island, and that's how you spell it in English, it's silent S. And the word isolate, right, is when you put something by itself, same 4 letters. So that's just a way of me remembering what I'm supposed to do here, okay? Now, the first thing I do is I rewrite what's over here, 3 2/5, and I give myself room because I know to get rid of a minus 3 2/5 or to get rid of a plus 4 200, I'm going to do what's called the inverse operation. The inverse operation, you can think of yourself as just like the opposite. What is the opposite of minus 3 2/5? Well, hopefully you said plus 3 2/5. That's also in math called the inverse operation of minus, and subtraction is addition. Now, I had an equation. I told you up there it was in perfect balance, and I just added 3 2/5 to this side. So now it's going to be out of balance unless I do what? I'll get out that bracelet. Do the same thing to the other side. If I do the same thing to the other side, you always just drill that. That's why this girl made me this bracelet, because I drilled that. I said it so many times that it was in her mind, right? So she thought it'd be cool to make that. So I'm very appreciative. Anyway, these are opposites. Opposites attract. They fall in love. They get married. They run away. They're gone. Just kidding. So all that's left here is an x, right? A plus 3 2/5, a minus 3 2/5. They cancel each other out. So all that's left on this side is the x, which is what I wanted. On this side, I have 8 5/8 plus 3 2/5. In order to add those, I need to get common denominators. So I'm going to go ahead and stack them. Okay. And 5 and 8 go into 40. So I'm going to change these to 40ths. And 8 times 5 is 40. So I got to go 5 times 5 on the top. Here I did 5 times 8 to get 40. I got 2 times 8 on the top. And when I add 16 40ths and 25 40ths, I get 41 40ths, which is a little bigger than one whole, right? 8 plus 3 is 11. So I'm going to use those 40 40ths to carry over, make that a 12. And then I'm going to have 1 40th left because I used 40 of them to make that extra number, right? Now, are you done? Well, if you're lazy, right? If you aren't, you're going to say, wait a minute, if this is true, if x actually equals that, I should be able to substitute that in for x and write 12 and 1/40th and see if that subtracting 3 2/5 is going to equal 8 5/8, right? So 12 and 1/40th, let's go and do that on back so we got some room. And I'm going to subtract 3 and 2/5. Let's double check before I do any work. Yep. And we're going to change these to 40ths. This is already a 40th. And when I go 5 times 8 to get 40, I got to go 2 times 8 and get 16. And now you're thinking, wait, you got 16 40ths you're trying to take away from 1? You need some more 40ths, Mr. Daniel. Go to Walmart, get some 40ths. No, I'm just going to borrow from the 12. Save me a trip, right? Now, don't put a 1 in front of that because that would mean that 1 whole gave you 10 40ths, right? 10 plus 1 makes that 11. 1 whole is 40 40ths. Okay, so 40 40ths plus that 1. Now I have 41 40ths. And when I go 41 minus 16, I get 25. Okay, and then 11 minus 3 is 8. Now 5 goes into 25 and 40, so I'm going to simplify this. 5 goes into 25 5 times, and it goes into 40 8 times. So 8 and 5/8 is my answer when I subtract that, which is, boom, that's what I wanted, right? So we checked it and we got it right. Okay? All right, I'm going to take a little break here to give you the secret question to get you to get points on this. Make sure you're paying attention. When you meet someone new, okay, you're old enough now to shake their hand. Okay. Now, with COVID, you might want to wait till this subsides a little bit, but all right, normally you would shake their hand. And when you shake their hand, you want to have what's called a firm handshake, right? That means you're going to grab that hand with a little bit of strength, and don't just sort of stick your hand out there like a dead fish. Okay. Grab it, shake their hand, you look them in the eye, and you say, nice to meet you. Okay, that's how you meet someone. You look them in the eye, you tell them your name, you speak up, chest out, chin up, and you speak up loud and clear what your name is. And you tell them when you look them in the eye, nice to meet you. But remember, no dead fish. No dead fish. Have a firm handshake. Okay, back to business. Mr. Daniel's weird. What are you talking about? All right. Our goal is to isolate the variable. So I have to get rid of this plus 4 and 200ths. How do you do that? The inverse operation, which is subtract 4 and 200ths. But if I do that, my equation becomes light on this side because I just subtracted something. It's out of balance unless do the same thing to the other side. What does that mean? If I subtracted 4 and 200ths from that side, I got to subtract 4 and 200ths from this side. Now it'll stay in balance. Now these things cancel each other out. All that's left over here is A, which is what I wanted. It's isolated. Here I got to go 18 and 3/10 minus 4 and 200ths. Now since that comes out to 10th spot, this comes out to 100, I'm going to go and add a 0 and say that's the same as 30 hundredths, right? 3 dimes is the same as 30 pennies. Now I write those one on top of another, 18.30 and 4.02, and subtract, and I get 30, whoops, I'm adding 28 hundredths here, and 18 minus 4 is 14. 14 and 28 hundredths is my answer. Are you done? No, if that's true, you should be able to substitute and say 14 and 28 hundredths plus 4 and 2 hundredths equals 18 and 3/10. Let's go up here and do it. You stack them. And 2 plus 28 is 30. 14 plus 4. So 18.30. And I can chop off that 0 that's at the end. Boom, we did it right. Okay, multiplying fractions is easy. There are different ways of writing multiply. When you see that word of in math, you can put a big X through it. And remember, why is it easy? You go straight across the top, straight across the bottom. Okay, straight across the top, straight across the bottom. Now I can simplify this because 4 goes into the top and bottom, right? 4 goes into 12 3 times, goes into 28 7 times. And remember, you can cross cancel. 4 over 7 times 3 over 4 is the same as, flip that, 3 over 7 times 4 over 4. Well, 3/7 times 4 over 4 is 1. I'm going to equal the same thing. This means multiply, right? Okay, now I'm going to cross cancel before I start. Check this out. If 5 goes into the bottom 1 time, goes into 10 2 times. Okay, 2 times 3 is 6, and 13 times 1, boom, done. Okay, how do you do this one? Well, there's different ways. Since this is kind of small, I'm going to go ahead and use a C method and rewrite this as a fraction. All right, 3 times 1 is 3 plus 2 is 5 thirds times 1/5. I can cross cancel, or I can multiply first. 5/15 simplifies. 5 goes into the top once, the bottom. Okay, now here's the key. What word would you want to see in all these? Okay, I'm going to give this in the directions. Hopefully you guys pay attention. Estimate. Why? Because estimating, your job is to make this easy. I don't want to multiply 378. That's too hard. Let's round that to 400. 62, that's too hard. Let's round that to 60. Now my basic problem is really like a 4 times 6 with 3 zeros, 24,000. Here, let's change that to 400. Let's change that to 70. 4 times 7 with 3 zeros, 28,000. 675, let's call that 700. Let's call this 30. 3 times 7 with 3 zeros, 21,000. Don't you love that word? Yeah, you're going to fall in love with this word. You should send this word a Valentine. All right. Now, when you are estimating with fractions, what you want to do, especially if you have a 1, but even if you don't, leave this alone. It's a single digit. And look here, don't round this to 200. Okay. Don't round it to 240, or I guess you can. Yeah. You're looking for a number that 4 goes into. And since 4 goes into 24, I'm going to change that to 240. Perfect fit. 4 goes into 240, 60 times. 1/3 of 88, what are you going to change this to? 90. 1/3 of 90 is 90 over 3. Divide 90 by 3, 30. 1/7 of 486. Let's change that to 490, not 500. 500 doesn't make it easy. Estimating is supposed to be easy. 490 makes it easy. Why? Because you end up with 490 over 7, or 490 divided by 7. That equals 70. What am I going to change this to? How about 2,700? 9 goes into 27. Okay, so 2,700 ninths is 2,700 divided by 9 equals 300. How about this? Let's go 150, because 5 goes into 15. Okay, so that's going to be 30. And let's go to 320 on this one. Okay, 320 over 8 is the same as 320 divided by 8, 40. Now, I did that fast. Rewind, watch again this part, okay? Because you want things to be easy. This is how you're doing it. Now, we've done these before. These fractions you haven't done before. But I want to remind you, when you go round, don't just round to a round number. See what this number fits into, if the denominator fits into. That's what's going to make it easy, not a round number. Remember, 500 isn't going to make this easy because 7 doesn't fit into 500. 490 makes it easy because 7 goes into 49. All right? All right, have a great day, everybody.